Hello and welcome. I know it's after lunchtime, but I hope I'm gonna keep you interested. My name is Karakoliou, and I'm a junior aviation professional. As you can see, there are three names on the slide. Cyril Rosset was the one supposed to give this presentation. Unfortunately, he had a parallel workshop. That's why I'm here. But since he has supported a lot for this presentation to happen, I thought his name would be nice to be there. Additionally, there is Davide Martini. This is my colleague sitting over there. Davide, can you? Yes? Davide has also contributed to the presentation. He is very good with animations. You will understand after the finish of the presentation what I mean. And he is also here to support with the questions. A small introduction about my team. Currently, we're 7 people. Cyril Rosset, Davide Martini, and Jerry Ngu are 3 senior cybersecurity experts. We have one principal coordinator, Jean-Paul Moreau. We have a security and intelligence officer, Matthew Hilsner, and Juan Anton Bernal is our section manager. We are getting one more colleague in the beginning of January next year as a security expert, and there is currently an open vacancy for a cybersecurity expert. If I'm not wrong, the deadline is 2nd of December. And from 7 people, we're going to be 9. So as you can see, EASA is giving importance to the topic of cybersecurity, and that is why our team is growing. I think it's enough with introductions. I plan to talk to you about 3 topics. The first one is terminology. I promise that I'm not going to cite definitions. And I also don't want to open a philosophical discussion. It's just so we can have a common language framework. Second, we're going to have a look at a case study. This case study shows a methodology for a risk assessment, a security risk assessment. And finally, we are going to have a look at the rules and how they affect you. Let's start with terms. In most European languages that I know of, Greek, French, German, safety and security, they're one word, and this makes our lives easier. But that's not the case in English. It's a very rich language, and safety and security, they're very often mixed with each other, but they're 2 different things. In my head, there are 2 separate concepts, but the one is an integral part of the other. Big organizations such as ICAO or EASA point out the link between safety and security in plenty of their definitions. For example, ICAO, in Annex 17, it's titled Safeguarding International Civil Aviation from Acts of Unlawful Interference. It's the annex about security. In the very definition of acts of unlawful interference, they write that these are acts that jeopardize safety of civil aviation. EASA, in the basic regulation, both in Articles 4D and 88, they state that interdependencies between aviation safety and cybersecurity need to be taken into account. Finally, Eurocam, in the glossary that they have, document ER 013, for those who are familiar, in the very definition of security, they write that the purpose of security is to ensure safety. So apparently there is a link between safety and security. What is also interesting is to think of what is the difference. In the case of safety in aviation, we consider that it's quite unlikely something very bad to happen. Why is that? because we have a lot of protection mechanisms. Let's assume that these circles represent these protection mechanisms. In the case of safety, it's very hard to align the holes in our systems. But in the case of security, there is someone with malicious intent that is going to align the holes in our systems, and they're going to manage to penetrate. So this is a very fine difference between safety and security. The notion of intent. Someone wants to penetrate in our system. Someone wants to align the holes and find a way. Bit more terms. I like to speak with examples. So I promise I'm not going to cite each and every one of them. For now, I'm only going to talk about cybersecurity and information security. To be honest, till now, I couldn't find a robust definition of cybersecurity in aviation. I searched a lot, there was nothing nowhere. So in my head, cybersecurity is just a fancy word for information security. It's a fancy word because you can use it with your line manager to get a bigger budget, or you can use it with the press to make a bigger buzz. But what you're talking about is information security. In the EuroGAIA glossary, the definition that is given is the following. Information security is the protection of information and information systems from unauthorized access, use, disclosure, modification, disruption, and destruction in order to provide three things: availability, integrity, and confidentiality. These three concepts, they are key and fundamental for information security. Confidentiality, what does it mean? It means that information is not available or disclosed to unauthorized entities. Entities meaning either individuals or processes. Integrity, it means that the information we're receiving or sending in our systems, it's accurate and complete. And finally, availability means that information is available and usable upon demand from an authorized entity. This is the baseline used to determine the level of security that is needed by a system. For example, if you want to have public information, then you don't need much protection for confidentiality, but you need to protect availability. So it doesn't mean that you have to protect all three elements. It means that you need to find the right balance for your system. I don't make these definitions from my head. They come from ISO 27000-2012. That's a very nice slide that I like a lot. So what is a vulnerability? This is a picture from a German university. And you can see that there is a street and a barrier. And it's for access control. So for someone to cross the street and enter the university, they need to have access. They need to check their credentials, and then probably the barrier goes up so the car can pass. Do you see the weakness? Is it there? So the designer of this system probably didn't think that the students would be all German. So if you're Greek like me, you could find another way to enter the university. So you can just go around and bypass the barrier. This is a hole in the system. This is a weakness. So any weakness in a system that can be exploited to expose information security is considered to be a vulnerability. And when we talk about a system, we talk about people, products, and processes. So whenever you have a hole, this can be a weakness that can be exploited. Failure condition or threat condition. This is a tricky one. So in the case of safety, usually we talk about failure condition, but threat condition has more to do with cybersecurity. Let me explain. So this is an example of a function used in an ACARS receiver. A string message is copied in a local variable. With strings, for those who are a bit familiar with software development, a lot of things can go wrong. For once, the size of the message is not checked here. So it says that it's 128 characters. So this is the function, this is the ACARS receiver, and it says that the message needs to be copied in a local copy, which is only 128 characters, and there is no check about the size. So what happens if the message is bigger than the space that we have saved in our memory? If the message is bigger than the size of the variable, then the memory gets corrupted. And that is what is called a buffer overflow. So memory corruption, buffer overflow, they don't sound very good. They can result in a crash, in a freeze, in a reboot, which we don't want. This is what we call a failure condition. It's a condition caused by an unintentional error or failure. But this can go even more wrong. So, like I said, strings are tricky. One can manipulate the text and force the system to react in ways that we don't want it to react. For example, instead of just overwriting the buffer and its size, it could mean that someone with malicious intent changes the text and inserts executable code. So for those who are a bit familiar, someone would say, okay, but how can you make the code to go back and return to that point to execute that code? This is also quite easy. In the return address, they can add a pointer and go up and make the code to be executed. So then we have a real problem, because in that thing, they can write wherever they want. So this is what we call a threat condition. It's a condition different from a failure condition because it's not an intentional error or failure, but intentional act of unlawful interference. Some with malicious intent has changed our code. So this was just an example to understand the difference between threat condition and failure condition. It's a useful term. Next, we're going to see a risk assessment, so we're going to use these terms. That's the case study we're going to look to show the methodology for a risk assessment. We're going to take the case of a remote data loader. So on the one side, we have the airline, they have the server, they have the LAN, and they need to upload software to an aircraft. So they can go via various ways, via the GSM provider or Wi-Fi at the gate, or they can have an actual person walking to the aircraft, have a USB with the software, plug it in the aircraft, and copy-paste the USB or upload it. That's the case study. How do you start? First, you need to define your security scope. The security scope has 3 parameters. 1, the assets. What are the assets? It's what has value to you, what you don't want to lose. It's the logical and physical resources of an aircraft which contribute to the airworthiness of the aircraft and its systems. Then, you need to think about your security perimeter. This is the notional boundary between the internal security context and the external security environment, meaning all the interfaces that interact with your assets. Finally, you need to think about your security environment. This is whatever is outside of your security perimeter, but is still relevant to the security of the aircraft or the system under consideration. This is how you start. The purpose of this methodology is to assess the risk. Before assessing the risk, you need to have a definition of the risk. So risk comprises of 2 things. The first thing is the level of threat. The level of threat refers to the likelihood. How likely is to have an attack? The other thing is the severity of the threat condition. What is the impact that could happen? So in this slide, we're going to start with the severity, so the impact. The impact is meaningful when we link it to safety. So we need a hazard classification like safety. So in the case of safety, we'd start with functions, such as, I can find it, such as the software upload. And then we would look for failure conditions. One of the failure conditions could be undetected errors in our software, like the one that we saw before with the ACARS example. What attribute does this compromise? Integrity. And one could say that if the aircraft is airborne, then the hazard classification would be hazardous because the severity would be hazardous. That's about safety. Now you need to think about security. First, you define your security scope, meaning finding your assets and your interfaces. The asset is the actual software, okay? And then you're going for the threat condition. The threat condition would be someone unauthorized uploading the software. And this is, I'm talking about threat condition number 3, upload of an unauthorized software. This compromises, again, the integrity of the information that we have in our system. So when the aircraft is airborne, we end up in a failure condition like we have in the first table, F5. So the result is the same. And that's how you connect your security risk assessment with your safety risk assessment. So one leads to the other. This is just the first step. This is the severity. This is how you calculate the impact. So in our case, the impact is hazardous. This is just an example, okay? The second thing that you need to determine is the level of threat. So the likelihood of an attack. How can we say someone has a malicious intent, it's 30% likely that somebody attacks? This is not possible to do. In the case of safety, it's a bit different. We have data and we have statistics to evaluate the probability of something. It's a probabilistic approach based on data. However, in the case of cybersecurity, it's not so easy to do. Therefore, we look at things that we do know to try to calculate the likelihood of an attack. One of these things, it's the preparation means. Meaning, if somebody has bespoke equipment, meaning very expensive equipment, and not much of a preparation time, then our level of threat is quite high, because anybody with a lot of money can actually attack. You have to reverse it a bit on your mind when I say effectiveness. So it's the inverse relationship from the level of threat, meaning how effective are your protection measures. In such a case that anybody can attack with very expensive equipment, the effectiveness is basically none. But that's not the only thing you can look. You can have a look at the execution means. We said we have a bespoke equipment, but what if we need an expert to perform the attack? That means that the effectiveness that we have is even higher because there are not so many experts out there. At the same time, the level of threat goes down. So effectiveness, just to be clear, so I went from 5 to 15 because we got 5 points from the preparation means plus 10 makes 15 points. So I add up, okay? I'm not going 5 to 10, I'm going 5 plus 10. So that makes our effectiveness higher. We are landing 15 points, and the level of threat is moderate. Keep in mind that the numbers is just a scale. Someone could choose different numbers or a different scale to do it. You could say A, B, C, D, E, F, G. You could say green, yellow, red. This is just to make my life easier because I work better with numbers. Finally, you can also look at the window of opportunity. So it's a different thing if the attack can be carried out at any time, and it's a different thing if the attack can only happen in a very restricted time phase. So if we assume that this can happen only in ground, in maintenance mode, then we land a few more points in terms of effectiveness. So our effectiveness is high, 21 points, and the level of threat is low now. This is a tricky part to understand. Likelihood is the inverse of the difficulty to attack. The more difficult it is to attack, the less likely it is to happen. Having defined these two things, severity and level of threat, we need to see our acceptability matrix. In the case of safety, in case of minor and frequent, it's red. But in the case of security, the matrix is a bit different. So the only difference is here 1 and 2. So in the case of safety, this is red, but in the case of security, this is green. I don't really know the reasons behind. It's the proposed methodology. The only thing I know that it was a consensus made by the ARACA-CISP discussions. So it was, the experts decided that we're gonna call it this way. So don't try to find something behind it, there isn't. It's just that they agreed that in this methodology, this works better. So let's see security. Let's assume that we land in the red zone. What do we do? One way is to try and reduce the severity. However, to do that, it means that we probably need to modify the architecture, and that is quite expensive. So it should have been better to have thought cybersecurity from the beginning. But that's not our only option. Our other option is to try to lower the level of threat. How can we do that? We can have more operational constraints, for example, or more protection mechanisms, or make the scenario more difficult. Like in the example that I showed you before, you can either use the GSM provider or you can have an actual person walking to the aircraft. Maybe that is more secure. These are just examples. I'm not saying that this is more secure than the other. It's just an example to know, to be able to think that if that doesn't work, we have to find another solution. We have to put more constraints. So I'm going to sum up what I've said till now, okay? This was a risk assessment methodology, okay? You need to start with your architecture. You need to think about the security scope, what is important to you, what do you want to have secure. Then you need to move on to your risk assessment. The risk assessment is two things. One, it's the level of threat, and the other one, it's the severity of the threat condition. Then, after you have completed this, you can move on to your acceptability matrix. Now, you have two scenarios. One, you're in the red zone. If you're in the red zone, you need to go back. You need to think your architecture, you need to make design changes, and you need to redo the whole thing again. The better scenario is that you're in the green zone. Then you can start preparing for certification and to communicate the evidence to the appropriate authority. However, that's not the end. How long does it stay secure? In the case of safety, we know that if we have a safety risk assessment, we have the data, we know how the system reacts, it stays safe for the next 20 years, 30 years. But that's not the case with security. Let's take the example of the famous IMC catcher. This is an eavesdropping device used for intercepting mobile phone traffic and tracking location data. So before 2013, this cost $100,000, which makes it bespoke equipment, okay? So our effectiveness is quite high, it's 21, like we said. But in 2016, this cost $20,000, which is not more bespoke equipment, it's just special COTS. COTS means commercial off the shelf. So it is expensive, but not so much anymore. Therefore, our effectiveness is now moderate. We went down a few points. And I had a search 2-3 days ago on Alibaba for an IMC catcher, and in 2019, it cost $450. That's not much. That anybody can buy. So, now this is considered to be standard equipment, and our effectiveness is down to basic. So one thing that you have to think about. Second thing, reality check. I had a look in the National Institute of Standards and Technology. They have a vulnerability database. So the last search that I did, it was 125,494 publicly known cybersecurity vulnerabilities. Does anybody check if you have this in your system, one of these, two of these, 3, 10, a million, who knows? And I don't know, is anybody of you familiar with the term zero-day? Zero-day vulnerability? Good. So for those who don't know, a zero-day vulnerability is a software vulnerability that is unknown or unaddressed by those who should be interested in mitigating this vulnerability. A colleague of mine gave me a research from the same institute, and it states that this lasts 6.9 years on average. So for 6.9 years, we have vulnerabilities in our systems that somebody can exploit, and we don't know about them. It's a long, long time for somebody to find a way and exploit the system. And now the last part, the rules. So we saw the methodology, and we saw that this does not solve everything. EASA has been dealing with the issue of cybersecurity for quite some time, and there have been a lot of discussions with stakeholders, and at some point it was decided that we need to materialize all the outcome of these discussions. So the first thing was rulemaking task 0648. This is to regulate certification aspects for cybersecurity. It's for products and parts covered by Part 21. And it includes generic cybersecurity requirements in CS23, CS25, CS27, CS29, CS Engine, CS ETSO, CS Propeller, and CS APU. It amends AMC 20 and adds AMC 2042. So the timeline. The terms of reference were published in May 2016. The NPA was out in February 2019, and finally the decision is coming out within the following weeks. So I can tell you for a fact that it is with proofreading, so it's coming in our way. You will probably ask, how does this affect me? So, till now, the cybersecurity issues were dealt with special conditions. And this is a graph to show you how does it work. So for legacy aircraft and new type certificate applications submitted before the publication date, they will continue to go through a special condition. However, for new type certificate applications and legacy aircraft with major significant changes, you need to apply the new rules after the publication date. Additionally, specifically for SDCs, there are 4 possibilities. 1, you need to justify that the change is outside of the security perimeter. Or 2, you need to justify that the system or the function is isolated for the aircraft systems. The third one, if it's not within the security, if it's within the security perimeter, you need either to involve the original manufacturer and ask for his risk assessment, or you need to provide the risk assessment and invest your own resources if you don't want to involve the original manufacturer. This is not very different from what was in the rules. So even the regulation coming up, replacing regulation 748 2012, so the one coming in place that Mikael told before, 2019-897, which is coming into force on the 23rd of March 2020. The text has been slightly changed, but it stays the same thing. You either need to come with an agreement with the manufacturer, or you need to provide the risk assessment by yourself. Next, rulemaking task 0720. This is going to last a bit longer. So the terms of reference were published in January 2019, the NPA in May 2019, and currently we're in the phase of the common response document. We have received comments, and experts are going through them so that we can submit the proposal to the Commission by summer 2020. As for the implementing rules and the decision, we are waiting for them after the end of 2021, and they're going to be published simultaneously. One thing that I need to mention, the decision is only going to have acceptable minutes of compliance and guidance material, not certification specifications. This rulemaking task introduces provisions for management of cybersecurity risks by organizations in all aviation domains, and that includes DOA holders. But what does it say? What's the content of it? This is going to be called the Part ISS, which stands for Aeronautical Information System Security. And the first thing is that it has common requirements for information security management system. The second thing is that you need to have external and internal information security reporting scheme. However, it gives you the possibility to integrate your ISMS into an existing safety management system, and you also have the possibility to be exempted if you show that you don't have cyber risks. That's what I wanted to talk to you about. To wrap up, we had a look in terminology. We had a look in a risk assessment methodology, and we talked about rules. It's time to answer your questions. Thank you.
Thanks, Angeliki. I think a difficult subject right after lunch, but you did a perfect job to keep everybody's tension. And we received a few questions, and I don't know whether you or Davide can answer already to some of them.
It's up to Angeliki to go through the question and tell me what you want to discharge to me.
Okay, I will. I need to have a little time to read them.
So the first one is, please specify what qualification experience is needed for a person belonging to DOAs to be allowed to access the cybersecurity, to assess the cybersecurity risks. So by memory, at least in the new MC 2042, we do not have any personal requirements so far. In the coming Part ISS, but well, we need to wait some more months or years, there will be personal requirements. So what is strongly suggested is that you involve people who has a certain skills in cybersecurity. They may come from IT from this very moment, and then you may integrate them in your staff in the future in a more consolidated way. So we cannot prescribe any specific preparation, qualification, or experience, but there are many certification schemes which can, let's say, provide assurance that a person that has acquired knowledge and has so the basic skill in order to carry out risk assessment or understand basic elements of cybersecurity and information technology.
I'm reading a question. In the scope of cybersecurity rule, someone changed the order. In the scope of cybersecurity rule limited to aircraft hardware and software and the loading aircraft software, the answer is no. This was just an example. It also includes air traffic management. Whatever is the scope of this. So the scope is much broader. This was just an example. Have I covered you?
And then eventually, if you cannot, I'm trying to also to interpret all the facet of this question. Is the scope of cybersecurity rule limited to aircraft hardware and software and the loading of aircraft software? Well, when we talk about certification, of course, we focus on the product and equipment. But then, if we talk about Part ISS, which is the other rule that is more for organization, well, it's more broad. We talk about processes, so it touches everything. It touches also processes within your organization, which is carried out by humans or machines which are interconnected.
I see one more question that I like. Any guidance for software coding rules and robustness tests to be compliant with cybersecurity requirements? Currently, both rulemaking tasks, they don't go so deep. They don't go so technical because it can differ. So it's not there yet, and currently it's not anticipated, but that's why we welcome any kind of feedback to move forward, and it might be one of the things that should be included in the future. Davide, do you have something to add, or shall I find another question?
I have to be honest, I didn't get which answer did you give because they moved while you were answering. Is it the first one? Any guidance?
Yes, it's the first one.
Okay. Yeah, I mean, there are, and again, we do not want to be prescriptive. There are many guidance, especially for what concerns software coding rules. If you want to take something home, well, let's think about implementing something like a red team, blue team. So one team which is specialized in developing security measures, and the other team which is specialized in trying to break things up, let's say, and breach the measures. So this is something which is very, well, uncommon if you come from the safety direction to trying to break things up, but that could be something that it would be is very effective and has been demonstrated to be very effective in security.
Okay, the order keeps changing, so I cannot manage to read one whole question. I think I was reading the last one, which was upper. Not that one. How will DOAs interface with TC holder security data, and will not be a vulnerability if all DOAs have access to this data? Davide, I think this has to do a bit with information sharing, and I think that's your field, so maybe you could take that over. It's the first one now.
The first one now?
Yeah.
Yeah. Yeah, okay. Yes, I mean, it is information sharing, but not exactly the information sharing we are trying to promote, which is voluntary. Here it's more a process which should be established. Well, but as Angelique has shown, there are different ways to deal with this certification in case the TC holder is not collaborative. Actually, with Part ASS, we will improve a little bit this channel of communication, because Part ASS will also ask organization to deal with cross-organization risk assessment, and although it's not really specific to certification process, well, will stimulate a bit more the exchange of information. For the time being, say, I believe that you have to choose, say, on the different option that has been shown, and eventually cope with non-cooperative TC holder.
Thank you. I see that this one has a lot of likes. So is it anticipated that cybersecurity risk becomes part of change classification process? I think certification colleagues are better equipped to answer this question.
This one is a bit, I would say, a recurrent issue we have. In fact, we have a CRE for cyber under development today, which is not under development, by the way, which is implemented on programs. So it is part of the normal discussion between the applicant, be it for a TC or an SDC, and our experts. So basically, the reply would be from a high level, yes, but for this particular discipline, it is more or less what I would say business as usual for certification projects. Only a new point, not so new in fact, a new point to be taken into consideration.
Do I have more time, or
well,
do we stay?
Maybe one last question. I think the one from Ian Bannister about the level of security protection degrades over time, as you showed in your example. Are rules for operators envisioned to address these change in the environment.
Rules for operators. I think operators are covered only by Part ISS. Davide, please correct me if I'm wrong.
Correct. Yes. In fact,
That these are the rules that they are going to address the operators. Part ISS. It's going to take some time, but it's on the way.
Yeah, just to integrate a bit, Part ISS will include provisions to monitor the risk, and so intervene if the situation changes, which we understood today, we learned today that is not really depending on our will, but it might be mutation in an environment outside. So we will ask organization to keep an eye on their risk assessment and keep it updated.
Okay, thank you very much.
Thank you, Angeliki. Thank you, Davide.